So now, these are supposed to be the same. Can you hear the beat?
Mm-hmm.
Yes?
You can hear it better on that one.
Yeah, this is the right frequency. All right? So here is a legitimate frequency. Okay? If this was the same frequency, then they should blend and just give you a huge amount of constructive interference.
Oh,
Okay?
so because when they're both on, you hear the like.
This one might be 256, this might be 256.3. Okay? In other words, they're slightly different.
And that's what allows us to hear
And that's why
the wavy noise.
the warbling, sort of, the warbling, all right? Now, what that, you can touch one and it'll stop. And what that warbling looks like up here is this.
get the other one.
All right? So if I come to this, and I go to
Hold
this,
this.
All right.
and
Am I videoing?
this,
Oh no, I just want to try it.
and I open, and I run. All right, now they're looking at the screen. I'm sorry that you're going in all sorts of
I
places.
don't think. Oh shoot! It is playing.
Okay, there it is. Okay, so look up here. Now, this is a mathematical set of beats, all right? And remember that interference is antinodes and nodes, all right? So, what you see there is 3 beats. And the 2 frequencies are 128 and 125. But let's do 256 and 258. All right? So that would be the beat that you would hear, and that's every second. So you would hear loud, soft, loud, soft, loud, soft, loud, soft, and you'd hear it at the rate of 2 per second. All
We
right?
don't need these anymore, right?
If this one was
What is
257,
Yeah, we don't need them. Just one.
then you hear that longer beat, okay? But it sounds to me like our beats are kind of high. So if we went to 259, then that would be 3 beats a second. All right, so what's happening in those beats, the loud part is constructive interference, the soft part is destructive. Loud, soft, loud, soft, loud, soft, okay? So that's an interference pattern with your ears instead of seeing an interference pattern with a string on the floor or a spring on the floor, okay? All right, so it's called beats. The interference of sound of similar frequencies is called beats, all right? Now, look at the 2 frequencies. I know they're hard to see. If you look, cancel. Maybe it'll work. Okay, good. All right, let me make it just a little bit bigger. All right, so if you subtract the 2 frequencies, a little bit too big. All right. Okay, that's right there. All right, right there. All right, if you subtract the 2 frequencies, you see 259, 256. How many beats do you get? 3. What's the difference in the 2 frequencies?
3 beats.
All right. So if this became 250, 260, whoops, that's horrible. All right, then you would hear 4 beats. So the rate at which the person, the orchestra leader, is listening, and I think he listens at 440. So he can point to someone and say, Sarah, you're off. You're 3 beats off. And what that would mean to Sarah is that her frequency is either 3 hertz low or 3 hertz high.
She has to listen.
So she has to keep listening until she gets the beats disappearing, okay? So if it was supposed to be 440 and she got to 440.5, then he would hear this long thing that's not quite right, all right? So orchestra leaders can hear this. Mrs. Colwell can't, all right? But, so 1 beat would look like this.
Wait, so they're able to tell
They
why?
can tell because they're trained. I mean, that's
So it's
their
like
life. Their life is being able to hear
Sorry,
frequencies.
The difference of probably like 1 or 5 here, we can hear.
Yes,
So he hears that kind of thing, but when a whole orchestra
right.
is
But
going.
he'll listen to each section of the orchestra.
Can I
And
Right.
then,
Ding
I
them at the
bet
same
you
time
are.
again to try to listen to it.
Sure you can.
Should I do it wrong?
Try hitting them harder.
You can hear it.
Mm-hmm.
And that's just like one beat apart.
I don't know what that is.
Probably not that much.
This
I mean,
one's 85. Wait, do it one more time.
Oh, you
I
have
have
a
tutor, yeah, I
frequency person? Oh,
Yeah, I
good.
have a tutor. I used to put her in.
Okay, so go
Yeah.
for it.
That one's 127.8.
Okay, so it's supposed to be 128, not 256. Okay, 120.
127.8, and
Okay.
that's a C. And this one is a B, really sharp. It's 252.
Aha! So
they're
they
not
are a
They're not the
whole.
same note. They're like
They are literally an octave apart.
They're a half step apart.
What?
Not anywhere near like I thought. Okay, so this is what?
That was 127 point something, 8.8, and this one's 252.
Alright. I need a stand.
127.
Point
What?
seven.
And this one was
Let me
2.
see if I can do that for you. Like this.
And it should have been 256, right?
Yeah.
So this is the one that's wrong.
Yes. Well, they're both out of tune.
Sweetheart, I would say they're 50 years old. They tried.
What note is this supposed to be?
That's probably not even written on there. Probably not even written on here.
Wait, this one's a B, right?
Louder that time. Too loud? Oh, I love that.
Oh.
That's how out of tune
That's bad.
it is. Yeah.
That's real
That's
bad.
a little, yeah.
Okay, what about this one? It's supposed to be 128. How,
Yeah.
what does it sound like?
It's really sharp.
You're not allowed to know this much music, but I'm very proud of you. I'm very proud of you. All right, so this one is, I call this light tan maybe, and this is dark brown. All right,
You want to write the frequency on here so you don't forget?
that's what we did.
Oh, you're gonna put it in.
Yeah, I'm just gonna stick it inside the thing. All right. Thank you, thank you, thank you, thank you, thank you, thank you. All right, so now we're gonna do this.
Water.
Are you ready? So now we're gonna come, and they need to see
All right.
this. So this is our second official lab. We've had a lot of
I'm like the
demonstrations.
cameraman
All right.
now.
So the first lab had two parts: the speed of sound of the pulse, and the speed of using the tension in a string to vary the frequency so that you can get what the density of the string was. Okay. Now what we've got is, what does that say?
That's says 263, I think.
That was
Sounds like
dumb.
263.
That was dumb. All right.
Yeah,
Would you get me a meter stick, my dear?
Yes, ma'am.
I think it was.
Who knows what it is now?
I think it says C sharp.
Now that
That
it's
wouldn't make any sense.
now that it's dropped on the floor, it's probably nothing remotely to what it used to be.
256.
All right, that's what it's supposed to be. All right.
Wait, so how does that change it?
It's bent differently now, probably.
Oh.
Well, every time you drop tuning forks, you sort of rearrange their their molecules, and so then they don't vibrate quite as well as they used to.
Oh.
Oh.
Zero down. Good. Okay. So now, are you ready? You're recording.
I am.
You're holding the tuning fork. When you hit the tuning fork with your hand or your shoe, but don't hit it with the table or drop it on the floor, all right? Then what you're going to do, what I'm going to do is you're going to hold the tuning fork so it vibrates like this. Yes, okay, but don't touch it, just above it, okay? And I'm going to start lifting this, and you should hear a resonant state. That is, you should hear a loud sounding wave. All right, so when you're ready. Okay, you cut, whenever